Hello everyone, welcome to the course Deep Learning with TensorFlow and Keras. In this course, we will see how we can work in the field of machine learning and especially in deep learning, and how we can do our task in this field, such as, for example, if you wanted to do classification, if you wanted to do the segmentation, if you want to do for example, image retrieval or other purposes that you need in your field. So, based on this short description of our purpose, we will start our course here. So, first of all, we should know what is deep learning. So, as a Wikipedia description of the deep learning, we can say deep learning is a subfield of machine learning concerned with the algorithm inspired by the structure and function of the brain called artificial neural network. So it's inspired from the brain, so it should work like a brain, and we will see how we can use it. So here you can see a simple neural network that we have an input. We have some hidden layers. So here it's one hidden layer, and output that is based on your classes if it's classification purpose. And here we will see a deep neural network. So deep neural network is actually is a kind of the simple neural network, but with the more hidden layers. As you see here, for example, we have 4 hidden layers, and here we have just for the simple one we have 1, and sometimes we don't have even a hidden layer for a simple network. And at the bottom we can see a convolutional neural network that we use instead of using neuron. In each layer, we will use convolution and pooling that I will describe it in more details in the next slides. So let's see how a deep learning can help us for our purposes. So actually, I can say it's using the deep learning. It's based on the amount of your data. So if you don't have a huge data, or can say big enough data, I personally don't recommend you to use the deep learning, because as we saw in this graph, the performance on the deep learning is based on the amount of data that you have. So if you are in the middle, or a little less than the middle, you can see the performance even for the other learning algorithm. It's a little better than deep learning. So if you don't have big data, so using the deep learning, sometimes you will get worse result. So be careful about this, and before choosing your algorithm, think about your data. Okay, we will start our course with writing a code in deep learning. So it is like the hello world. When you want to learn any programming language, you will print hello world. But here in the machine learning and deep learning, when you want to do such a hello world example, you should do a digit classification, I can say. And digit classification, it's usually done by using the database that is called MNIST, that is hand written digit classification. So it is consists of several handwriting digits from 0 to 9, and we usually use it for classification, digit classification. So before going to our script and write our first code, first I should define some verbs or notifications that it's then later it will be easier for us to understand what we are saying and why we use these notations. So the first one is deep learning, and we know what is this. And again, I will repeat, deep learning is a subfield of machine learning concerned with algorithms inspired by a structure and function of brain called artificial neural network. The second one is the TensorFlow, that we use it for this course. Actually, the TensorFlow is a powerful data flow-oriented machine learning library created by the brain team of the Google and made open source in 2015. But actually, it is such a library that we can use to implement or algorithm in deep learning. So you can use other libraries such as Caffe, PyTorch, or any other deep learning platform. But the TensorFlow is the newest one, so we will introduce it. And then we will use Keras. And Keras is the high-level neural network API written in Python and capable of running on top of TensorFlow, Theano, and CNTK. So these are the three platforms for using for writing your code in deep learning. So the next session is the batch size that we consider. Actually, the batch size is it's defined the number of samples that going to the propagate through the network. So we send not just one image or one type of data to the network. We send a bunch of the data. So that it's called we call it batch size. That is the size of that batch. So for example, if you have 1,500 training samples and you want to set up a batch size equal to 100, algorithms take the first 100 images or samples from 1 to 100 from the training data set and train the network based on these 100 images. And then you will send the next 100 images to your network from 101 to 200, for example, and so on till the end of your training data. So it means that we should do this 15 times as you have 1,500 images. So when we send all our data once to a network, we call it batch size. We call it epoch, excuse me. So it's the way that network is trained once on our data. So we will do this several times. It's based on your data and your algorithm. We can do, for example, 3, 4, or even 10 times, or even go up to 300. But usually, I haven't seen epoch size more than 150 to 200. So, but you can define it as you want. So we also use error or loss, and this is the difference between the predicted class and the true class. So your network predict a class, and you have the ground truth as well. So when you compare these two results together, you should find a distance between these two. If it is the same prediction as the ground truth or the true class, so the error or loss is 0. But if it's different, it will report a value that we call it error or loss, or we can also call it a loss function. And here you can see a question how we can use the cross entropy loss or cross entropy error on our data. So the next one is accuracy. Usually if you have a look at the deep learning papers, you will see these two notation, error and accuracy. So, and the accuracy is the correct classification over all true classes. So you have the correct prediction classes, and you have all true classes, and the ratio that we get, it's reported as the accuracy. And the last one is a softmax function. So actually it's calculate the probability distribution of the event over n different events. So for example, when you have 10 classes, it will calculate the probability of each classes, and it gives the maximum probability to the class that the network thinks it is the true class. So we will also talk about this in more details later. So, okay, by knowing this, we will start our first simple model. That is just a softmax classification, we call it. We have an input and we have an output. So for the input, we have an image from the database, and all the image on the database has the size of the 28 by 28 pixels. So when we wanted to give it to our model, first we should stretch it, or we can also the flatten. We make it flat, and then feed it to the network. So when we stretch the image from 28 by 28, we will have a vector or array of 784 pixels. So and then we feed it in the network. So we have some weight and bias here. That these weight and biases will update themselves based on the algorithm that we use in the propagate way. And then we have output here, and the number of neurons in the output is based on the number of classes that we have or we want in our purposes. So we use a softmax to do this, and what softmax will do is multiply of omega, that is the w, excuse me, by the x, that is our input, plus a bias that it will somehow penalize the weight to not go very high and not go very down. So keep it in the middle. So what we will do this, if we consider a matrix, matrix of images. So each row of this matrix is one image that is a stretch. So and we have 100 images. We call it a batch of 100 images. So as I said, for the first row we have the image of number 8. For the second one we have the image of number 4. Third one number 6, and so on. So and we should define a matrix of the weights. This matrix has the 10 columns based on the number of classes that we have. If you have, for example, 3 classes, your matrix of weight matrix should be should have the just 3 columns, and 784 lines. That is corresponding to the size of the columns of input matrix. So then we just multiply these two together like this. We multiply this by the omega 0, 0, omega 1, 0, and so on. At the end, we can get, for example, L 0, 0 for the first one, and then L01 for the second, L02. That is corresponding to the first row of our data. And then we plus it with the bias. That is the fixed number for all the images, and we repeat it for other rows in our image. So at the end, we can get this equation that we will see here by the L plus B, and the L is the multiplication of the input by weights. So to calculate the cross entropy error, as we saw before, we have this equation for the cross entropy, and we have a one-hot encoding vector. One-hot encoding vector is defined an array of equal to number of our classes. Here we have 10 classes, and the probability of each of them are 0, except the one that we wanted to predict. For example, here if we assume that 6 is our a true class here. You see other values for other classes are 0. And then yi is our predicted class. And the softmax will assign, as we said, assign a probability to this. For example, it assign a probability of 0.1 to 0, 0.3 to 3, 0.2 to 4, and 0.9 to 6. So it gives the probability, the highest probability to this number, and then the distance between this probability and this probability is reported as an error in our work. So by knowing this, we will move to Jupyter Notebook. It's the platform to write your Python codes, and we will use Keras to write our code for TensorFlow. So I will show you how you can use the Jupyter Notebook. So at the beginning, I should say that you should install Python, Jupyter Notebook, TensorFlow, and everything on your computers. And then when you want to open Jupyter Notebook in the current directory, on the address bar you just write cmd, and you open a terminal, and then you can write Jupyter Notebook. Okay, and then it open Jupyter Notebook for you. So we will start from the simplest one, or simplest model, that is the softmax. So here we have a code for our model. So we will start from the beginning. So when we want to use the MNIST database, we have to call it. So we can call it from the Keras database import MNIST. And then if we wanted to plot and see visually the images or images, we can use matplotlib library, and then we call our data, or we can say we divided our data to the training and testing. So we train our network on the training data, and then we test the network on the testing data. So we can do this by just writing mnist.load data, and then it save it on the xtrain. This is the images will go there, and ytrain, that's the label of that image that goes there, and the same for the x testing and y testing. So if we want to visually see the images, so we can just open use the matplotlib and subplot the first image that is in the xtrain 0, and we wanted to see it in the grayscale, so we can say just show it in the grayscale. And then for the second one in our train database, and then the third one. So here, for example, I show you that, okay, if we show the same images, number of images, it shows the same number of image here. So let's run it. Let's run it, and when we run it, it try to load the data, and then splitting on the xtrain and one train and xtest. So okay, when it's became 1, from a star became 1, it means that it's already run. And if we wanted to see it, you see, okay, we show that, okay, 500 as the first 2 images in our database. If I change it to 2 and run it again, you see 504, 3 images that we have, 3 first images that we have in our training database. So, and then we need other libraries to implement our or model. So we need the sequential library when we want to write our layers. We need this this library. We need to import dense for the dense layer, the layer that has has neurons, and the activation for the make it active or neurons. We will talk about this activation function in more details next slides. And then the layer we use a dropout. We don't use it now, but later we will use it. And NumpUtil that we will use. These are the libraries that we need for our implementation of our model. So, but first we should reshape our train data and also our or the test data into the as we wanted to make it flat. As I said, we stretch it or make it flat. So we stretch it or reshape it in a way of 784 for the train, and also for the test data we do the same here. We can do the normalization. It's if we do the normalization, divided each pixel by the 255, so our value will be between 0, 0 and 1. This is just the normalization. You can do this without this normalization, but it's suggested to do this normalization. And then as we saw, we wanted to convert our true labels or true classes to one-hot encoding output. So we use NP-utils to categorical for the training, and we also do for the testing. So, and then we will make our model. As I said, we use a simple model. We can write model equals sequential, and then 10 layer of the softmax that is equal to our classes, and we do the activation that is the softmax. Okay. Then we should compile our model. We define a loss function. We consider a categorical cross entropy that we saw, and we can use an optimizer that it can be Adam. So we can use other optimizer, and we will talk about this in more detail later. And then our metric that we wanted to see, that is the accuracy. Okay, and at the end we fit it with feeding the data, X data, that is our images, and the Y data, that is our labels of our images. And then for the validation data, that is here we have tested. We consider test data for this validation. We have X test and Y test. So we define the epochs as 10. It means that we wanted to feed our whole database of the training 10 times to the network, and a batch size of 100. In each step, 100 images will go. And this variables is just to show the after each epoch or after each batch size, it shows you a graph, or it shows you a bar, and so on. We will see it. So we run the first part. We will run the second part. We import the libraries. We reshape the training data, and then normalization, one-hot encoding, and model sequential, fit, compile our model, and then fit. So, and then you will see that, okay, train on 60,000 samples, validation on 10,000 samples, and this is the bar that I set. So as you put variables 1, you will see this bar, and it generates after each epoch your accuracy of the training and the testing. So here you can see that, okay, it took 8 seconds, So we see the loss function of 0.62 almost for the training, and the accuracy of 84% for the training and 90 for the testing. So when we go for the next epoch, we see that okay, the validation accuracy or testing accuracy increased to 91 almost, and then 92, and it goes it's adjust the weight and biases in our model in order to increase the accuracy or reduce the loss function in our model. So as we define a 10 epoch, at the end we can see that okay, this is this almost stop at the accuracy of 92%. So by such this model we can reach an accuracy of 92%. So it's just description of the very simple model on the TensorFlow and Keras. So for the next videos, we will see how we can visualize it, because right now we saw some values of accuracy and loss function here, but later we wanted to show this value on a graph, and how we can analyze these results on the graph and see how it's behave. We will talk about this in the next video, and we will also talk about more the deep layers for such this classification example. Okay, see you at the next video. Thank you.